Welcome to another video from Lockdown Electronics with me, Bill. And as a result of doing, I think it was 4 or 5 new to oscilloscopes videos, 1 or 2 people have asked me if I could show the scope being used to investigate specific components or specific circuits. So I thought what it might be quite good to do is start with something like this. And this is a fairly old 1950s intermediate frequency transformer that I've recovered from a old valve radio scrap chassis, and the component itself is working fine despite its vintage. It's older than me, so it really must be getting on, but I think it's quite a handy little device to have a look at and to see what we've got, and to look at how it responds at various frequencies. I'm going to do that using the oscilloscope initially, and hopefully along the way you'll learn a bit about IF transformers if you don't already know, and you'll perhaps also see the scope doing some exploring of circuits. So let's go straight to the bench. Okay, so got a couple of IF transformers here. Today we'll just look at this sort, and this is one of 2 that I recovered from a 1950s radio. I think off the top of my head it was an Echo EK Cole, British made radio. And what you've got in here is effectively is a transformer with adjustable cores. Now on a circuit diagram, you'll just see, if you look there, this is the circuit symbol you'd usually see. So it looks like a variable transformer. In reality, what you've actually got, you've got 2 cores. There's this one here which is adjustable, and that one at the bottom which is also adjustable. It's easier to use a trimming tool to adjust it, but you've got both. So in reality the circuit symbol would look a little bit more like this, where you've actually got 2 coils which interact with each other, but you've got 2 cores which are sort of separate and can be independently adjusted. And to be even more precise, what we've actually got, both coils are actually on the same former. Each has got a core inside it. So a better circuit symbol would be this one, so you'll have a coil and another coil. You've got your 2 independently adjustable trimming portions, trimming cores, and for completeness sake it's surrounded by this metal can, which is actually quite important. So what I'm going to do today is I'm going to use my rapid electronics signal generator initially, and I've got that producing a frequency around about between 300 and 500 kilohertz. Now I've picked that frequency because the intermediate frequency in these radios was about 450 kilohertz, and that's what these coils are designed to work most effectively at. But the reason I'm going straight for an analog signal generator is it's just really easy to alter the frequency, and you can hopefully see the wavelength changing there on the scope as I do that. So that's what I'm going to do, and then we can look at the response of the coils. So I'm going to just alter the camera position so that you can see the scope and the transformer, and then we'll carry on. Okay, so here's the transformer set up, and I'll just explain exactly what's going on here. So signal generator is feeding into this side of the transformer. That's one of the coils, and I've also got the yellow trace on the scope measuring exactly what's going on the primary, if you like, of the transformer, and then I've got the green trace attached to the secondary. Now I mentioned the can is a screen, and indeed it is. So this screen is connected to the tuning slugs, but it isn't connected to any of the transformer parts of the transformer and of the coils, but certainly when it's installed in the radio, there'd be a couple of screws going here which would hold it to the chassis. It'd be a metal chassis, and so this would definitely be grounded. And so I'm going to simulate that. I've just got this little clip lead. It's just attached to the ground side of one of the scope probes, and I'm just going to clip it on there. And I'm actually going to in a moment or two show you why that's important. So I'm just going to readjust the camera now so we can look at the scope traces, because there isn't very much to see there except me using the trimmer tool to adjust. That's the lower tuning slug or adjustment slug, and the top one is similar. So right, let's go and look at the scope trace. Okay, that's the scope view, and what you're seeing here on the yellow trace is the signal that I'm feeding in from the signal generator, and I've simply got the probes connected in parallel with the signal generator, so we're seeing what's happening on the primary coil. Now on the second trace, which is green, I've got what's going on the secondary, and we would expect the amplitude to be different, so I'm not too concerned about the amplitude right now, but you can see, hopefully clearly see there, we've got yellow and green traces. So currently, appreciate that's not going to be easy to see on screen, but we're at about 395 kilohertz, something like that, and I'm going to now just gently sweep the signal generator upwards. I'm just doing it by hand. That's about 415 kilohertz, and that's about 450 kilohertz, and suddenly you can see a very quick and rapid increase in amplitude of the green trace, and by 460 kilohertz, which is about there, it's fallen off. So there's clearly a very if you like, distinct sweet spot, for want of a better word, and we can sweep backwards and forwards. That's down, that's back up, and you can see there's definitely a very strong response at a certain point. So let's now just try and peak that just roughly by eye, and I think it's about there, and that's 450.39 kilohertz. So I mentioned these were designed to work at about 450. Quite often the intermediate frequency was 455 kilohertz. So yeah, we've clearly got a response there. Now currently I've not got the clip lead connected to ground, so the can is not grounded. So if I put my hand on the can, you can see there's a definite change there, and I think if I just maybe reduce the frequency, but it's even no, it's about the same. So what I'm now going to do is I'm now going to attach the clip lead. So I'm going to try. So the case is now grounded, and I'm touching it again, and as you can see, I can recognise just the tiniest change, but hardly anything. So it really doesn't matter that the can is grounded. And again, let's just try and tweak that now, see if we can get the strongest response there with the grounded can, and yeah, that's saying about 448.5 kilohertz, something like that. So yeah, we've clearly got a peak there, which is what the transformer is designed to do. So now what I'm going to do, I'm just going to hold it down on the bench, and I'm just going to use the trimming tool, and I'm going to adjust the lower trimming slug, and let's see if we can make any difference to what's going on. Currently there we're making none whatsoever. Let's see what happens when we tweak the top. Now there's quite a considerable change there, look. So depending on where I tweak that, we can get a change in response. So what I'm now going to do is I'm going to adjust the signal generator to 455 kilohertz, or as close as it'll go. Remember, this is an analog generator, and back in the day, of course, this is what they would have been using. So that's about 455 kilohertz now, and I'm now going to adjust the top slug as best I can, and let's see if we can get some performance out of the radio. There we go. So we can pick it up there at 455. That's the top slug, and let's just see if we might get any difference with the lower slug. Sometimes we do, depends on how it's configured in the circuit. It also depends on what kind of condition the cores are in. I guess no, I'm not getting any real change there at all. So it's the top slug that's making the difference. So it's possible there to tune that to 455 kilohertz and get a very distinct response. And if I now sweep backwards and forwards, you can see got that peak. So let's see if we can just recognize the peak without looking at the frequency and just see what we get. Yeah, 454.5 kilohertz. So that's essentially how the transformer works. And what we've got there is we've been able to use the amplitude display of the oscilloscope to see what's happening where frequency is changing. Now that's helpful to an extent, but wouldn't it be much better if we could see the shape of that change in amplitude as the frequency changes? So I'm going to reconfigure the setup now and see if we can achieve that with the display. Okay, I've reset up the scope, and this time I'm now using my Siglent STG 1032X signal generator, which is capable of outputting a pulse. So I've now got the pulse signal being fed into channel 2 of the scope, which is this purple trace here, and I've got the signal generator sweeping between 450 and 460 kilohertz, and I've got it doing that every 450 milliseconds for no other reason than it's a good enough time. And the way the output pulse works, and this is quite a common feature on signal generators, and I have done a video on this setup before. I will put a link up top to that if you want to see how that's set up. But even if you've not got a signal generator that's sweeping, it's still possible to do this, and there's yet another video which I'll put a link up top to, which allows you to do that too. But essentially what happens here is every time the sweep starts, there is a pulse on the output of the rear of the signal generator. So I've got that now fed into channel 2, and I've told the scope to trigger from channel 2. So what we've got going in looks a bit odd there, but if essentially that is the signal that's sweeping, and because of the length of the time base here, it doesn't look like a waveform, but I can assure you it is. So if I now adjust the time base to just make those pulses a little longer, like so. So that's the signal that's going in, and there is a little dip just there, and I'll come back to what that is in a minute. But I'm going to turn that signal off, and I'm going to turn on the output signal, which is the green trace, you may recall. And we've now got a very different kind of thing being displayed there. So input signal is the yellow one, output signal is the green one, and the little dip, if I now just go back to the yellow for a minute, that little dip that you can maybe see right at the top there corresponds almost exactly with the peak that the transformer is set to. So as the maximum amount of energy is transmitted through the transformer, you can see there's a little reduction in the signal on that side, which is understandable. That's the two halves of the transformer influencing each other. So I'll turn that off, and we're just going to leave the I need to leave the triggering trace on, otherwise we'll lose the trigger. But if I now turn up that, what we're seeing there is the response curve, and because I'm using channel 2 to trigger every time the sweep starts, what you're actually seeing now is amplitude against frequency, because I'm controlling the time base of the scope by the length of the sweep, if you like. So if I now do a little bit of, I'm trying to do this without getting my hand in the picture, apologies. If I now wind that trace down to the bottom there, like so, could maybe even risk turning up the amplitude a little bit and just wind that down a little bit more. that's the kind of display you would see on a spectrum analyzer, and what you've effectively got there is the shape of the IF filtering, if you like. Now if we move one of the slugs in the coil, so I'm going to just move the top slug, we should be able to move that, and indeed there it is. It's moving the frequency down there, removing the frequency back up as I wind the slug the other way. And that is how you would set up your intermediate frequency in your radio to, if you like, net in on the center of the IF frequency. I'm just going to see if we can make any difference with the lower slug. Going to wind that right out, and it's not making a great deal of difference. And if I'm afraid I'm going to lose the trigger there, unfortunately, but you're getting the general idea. So what we've managed to do there is we've managed to use the scope to show us a plot of frequency against amplitude, and you could certainly use that for, if you like, tuning the radio and also setting up the IF. So having turned our scope into a spectrum analyzer, let's just see if that really is true, and let's just use the same connections, but this time we will attach them to a spectrum analyzer and see if the spectrum analyzer gives us a similar kind of result. Okay, here's the same transformer now attached to my spectrum analyzer. If you're familiar with spectrum analyzer, then you can skip the next bit. If you're not familiar with it, essentially a spectrum analyzer gives you a display of frequency against energy or power or amplitude, whatever you want to call it. So I've currently got the display set up here. So the center is 455 kilohertz. I've chosen that, and the analyzer sweeps across. You probably can't see it terribly clearly, but there is a little red dot, which is the sweep of the track. Now I've got it set to 1 kilohertz bandwidth at the moment, so I get a sensible speed trace, so you can see the changes fairly quickly. But the other thing that a spectrum analyzer also got is a tracking generator, which is a signal generator that outputs a signal at the same frequency as the sweep. So what we're able to do is feed the tracking generator into the primary, a bit like I was using the signal generator, and we're looking at the output of the secondary actually on the trace here. Now I've tweaked it so that we actually get 455 kilohertz in the middle, but you can see the very clear shape of the IF selectivity, if you like. And what I'm now going to do, I'm just going to use my fingers to do this. If I move the top slug a little bit like so, you can hopefully see I didn't move it very far there, but straight away we've moved up frequency. You're seeing a total span here of about 35 kilohertz from the left hand side to the right hand side of the display. So using that slug, if I tune it right down, I can pretty much take it right down to about that's about 437 kilohertz there. And if I wind it back up a bit, let the trace catch up, it's possible to tune that up. Yeah, I can actually get it off the top of the scale there at about 472.5 kilohertz. So you can hopefully see that we were able to get our humble oscilloscope to give us some useful information in terms of if you were going to try and set up the IF of a radio. And if you've never done that, yeah, you can take measurements here if you want to, but in reality what you're looking for is where the center of the curve is placed. It should be in the middle of the passband for the IF, and then if this was working in conjunction with the second transformer, it would be possible to alter the shape of the skirt, if you like, so where the rejection of adjacent signals occurred. So if we had a strong signal here and we had a weaker signal there, you'll be able to work out how many dB of attenuation you've got going on as you come down the slope. So there we go, that's some practical use of scope as a spectrum analyzer, and we've just confirmed it using a real spectrum analyzer. Okay, well, hopefully you've seen a practical use of oscilloscope and signal generator there, and you could certainly make some measurements without doing all the fancy stuff that involves synchroing the scope with the signal generator. You can certainly discover what the resonant frequency of those transformers was set to, and with a few simple modifications using a timing signal from the scope, you can also produce a display that shows frequency against amplitude, and we confirm that with the spectrum analyzer. So I hope that's been useful. Again, to those of you who've been buying multimeters and things from Kaiweets and using the code I think it's LE10, thanks very much for that. That's a genuine help to the channel, and you get discount too. If you're thinking of getting a multimeter or something like that, do check out the links in the description below. As I say, there is a discount available if you use the code, and again, that helps the channel. Whether you do that or not, if you've not subscribed, please consider doing that, and definitely please click that thumbs up. That really helps the channel too. Neither of those will cost you anything. Thanks very much for watching. See you on the next video.